Okay, we are going to work on applications of systems of equations, and we're going to go ahead and move down to number 2. It says, let x and y represent the measures of a pair of supplementary angles. Supplementary angles, this is a geometry term. It's not one that I expect you to know, but what it means is two angles that add to 180. So basically, if I had a 90 and 90 or something like that, that's what we're talking about. So it says we're going to let x represent one of the angles, and we're going to let y represent the other one. So part A says what two equations can be formulated from this problem situation. So if we read, x and y represent the measures of a pair of supplementary angles. One angle, we don't know which one, they don't tell us, but one of them is x and one of them is y. So let's just call this one x. Remember, is our equal sign. So 36 degrees less than twice, which is our 2, the second angle, which is going to be y. So if we go to set up an actual equation for that, okay, we would have x equals 36 less than something. So we know we're going to be subtracting 36, and it's from twice the second angle, which is y. Okay? So that's the equation that we get from the sentence, but we still need one more equation because it says two equations. Well, the first one is what I told you, two angles that add to 180. So x plus y should equal 180 degrees. So now it says solve the system. Well, in order to do that, we have to have them in standard form. Again, remember standard form for a 2 by 2, because this is two equations with two variables. So the first one, we have our x. Y is on the wrong side, so we would have to move it over, so it would become negative. And then we would have equals negative 36. And then this is x plus y equals 180. So now you are ready to do your matrix, and then your matrix solution, and then you guys can give me an answer. Okay? All right. Let's flip over to the back side. This says this is another type of problem situation. It's about rate and mixture type problems. It says we could set up two equations and then solve manually. We're not going to solve manually by substitution or graphing. We're actually going to use our calculator to solve by either using graphing or the table. Okay? So let's take a look at number 3. It says Green Grass charges a flat rate of $15 per hour for lawn services. Their main competitor is S&G Lawn Care, who charges an initial fee of $30 plus $10 per hour. So they've given you this table, and it says for 1 hour for green grass, they want to know how much it's going to cost. And there's that box that says process. They're basically just kind of wanting you to show the process of what it would be. So for green grass, it's a flat rate of $15 per hour. So if we're there 1 hour, I would do $15 times the 1 hour. So that would be $15. So then part 2, this would be 15 times 2, which would be $30. 15 times 3, which would be $45. So on and so forth. So you could go ahead and fill this out, and you would keep going with the pattern. If you don't believe me, remember you can use your calculator. And then I know they didn't put these, but I'm going to go ahead and fill these two out. and we would get $90 and $105. Okay, so now it wants to say, what is our general statement? Well, no matter what hours, it was $15 times however many hours there were. So we'd do 15 times x, which is just 15x. So there's our general or generic equation. So now let's look at S&G lawn care. No matter what, S&G is going to charge you $30. So for every one of these, I know I'm going to have $30 as part of it. And then it says, then plus, so plus $10 per hour. Well, here on this first box, it's 1 hour. So that's 30 plus 10, which would be $40. And then this is going to be 10 times 2. Well, that's 20 plus 30, which is $50. And then this would be plus 10 times 3, plus 10 times 4, plus 10 times 5, plus 10 times 6, plus 10 times 7. And I think you can kind of match the pattern, but 30 plus 30 would be 60. 40 plus 30 would be 70. 50 plus 30 would be 80. 90. And 100. So our general equation for S&G lawn care would be 30 plus 10x. So that would just be 30 plus 10x. And again, notice it tells you y equals the starting or base amount, which is 30, plus the rate times x. So that's exactly what we did. Our base amount is 30, plus the rate times x. For them, the starting rate or base amount is 0 because they don't charge a flat fee. Okay? So it says use the pattern in the table to write algebraic expressions to represent each company. Well, that's what we have right here and right here. So y equals 15x would be the first one. And the second one would be y equals 30 plus 10x. So now it says extend the chart to find where the charges for each company is equal. Well, we already extended our chart. Verify this by finding the solution to the systems of equations graphically and algebraically. So if we look in the table, 60, 70, close, 75, 80, but here is 90, 90. So it's at this line right here where we are at 6 hours that they both equal the same amount. So we've got 690 as the solution. At 6 hours, both companies charge $90. That's what that means. So now if we wanted to solve it algebraically, we would set up our systems of equations. So we'd have to move this over here for standard form. So that would be negative 15x plus y equals 0. For this one right here, we would move this over here. We've got negative 10x plus y equals 30. And then you could go ahead and set up your matrix to get your matrix solution to get the answer. Okay? And then also notice it says graphically. So I just want to show you guys real quickly what it would look like graphically. So if I go into y equals, and I put in 15x for my first equation, and I put in 30 plus 10x for the second equation, and I hit graph. Notice that it's a really tight screen, and we know that it's supposed to intersect somewhere over at 690, and this only goes up to 10. So I'm going to go in and I'm going to change my window and see if I can make it fit. X represents hours in this case, So let's just keep it going from 0, and let's go up to 25 hours. And we can count by ones, that's fine. For y represents our cost, so we can't be negative in the cost. And let's go ahead and go up to, let's say $500. And we're going to count by tens. So now if I hit graph, I should get a little bit nicer graph where I can see kind of what's going on. And now I've got a clear intersection right here, so I could do second, calculate, 5, enter, 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 and notice it tells me also 690 is the solution as to where they intersect. So that would be graphically finding where the two are equal, or remember we can always look at the table. Let's see, I want my table settings to go by ones. So now up here we see 6, 90, 90. And this should look exactly like our table on our paper. Okay? Alright, so then let's look at the bottom. It says, explain how to determine when it would be better to use green grass ink and when it would be better to use their competitor. Well, if you look, green grass is cheaper. Cheaper, 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 cheaper. Here they're equal, but all of a sudden here, green grass is more expensive. So we would say I would use green grass up until 6 hours, and then after 6 hours, I would switch over and use S&G Lawn Care. And so that's what we could put down here at the bottom. I would use green grass ink for a job less than 6 hours. If more than 6 hours, I would use S&G Lawn Care. Good. So you guys need to go back and fill in the matrices and get your matrix solution. Other than that, we're done with that problem. Alright, I don't want this video to get too long, so I'm going to go ahead and stop this one, but you need to go ahead and turn it back on. There'll be one more video for the last problem on the back, for this one at number 2.